like to welcome everybody and thank you for taking time out of your days. My name's Dan Burdette. I'm president of 3-Tier Technology. I kind of wear a lot of hats with the company. I run the main operations, but a primary job that I have is designing all the products that we use. So a lot of my time is spent doing things like this, being on the road, talking with different industry people, getting better understandings of the challenges that you have, solutions that you don't have, that you'd like to have, or ways to improve upon your operations. So today what we're going to do is kind of go through a little bit of a rundown of some of the primary things that challenge the gas and oil industry on a pretty consistent basis. Give you a little bit of background on some of the challenges that these problems generate and some of the different ways that are available to go ahead and correct them. Also, hopefully we can give you some thought on different techniques, different processes that you may want to consider. My goal today isn't to make this a sales pitch as much as it is to try to be very open from the standpoint that there are a lot of choices and a lot of products out in the marketplace. Our products offer some new ways of doing things, but there's also a lot of other good techniques and a lot of products that are out there. So hopefully through the process that we go through, you're going to get some better education on how produced water spills impact your soils, how hydrocarbon impact your soils, how we can clean them up differently, faster, quicker, better, and look at alternative ways of general maintenance, because back in 2009, I had this discussion earlier, when oil prices crashed the first time, or most recently, directional drilling wasn't something that was really used in the industry. As soon as the oil prices crashed, directional drilling exploded. Why? Because they figured out they could save a lot of money. When the industry is flush and doing well and making money, they don't necessarily look at new alternatives or different ways of doing things. Today, they are hungry for new solutions. And it's evidenced by you guys being here today to look at different ways of doing things, having new ways of doing things, and that's what we're here to go ahead and provide you. So the basic topics in the order that we're going to do it is just a little bit of background on how our technology works and how our company works in servicing the industry, produced water spills, hydrocarbon remediation, some new thoughts and processes on hygiene and cleaning, and new products that should make it a little bit easier for you. And then some basic wastewater, which I know that's the reason why we kind of drop it on to the end is it's probably not something as much that you all are dealing with on a regular or day-to-day basis, but we also deal with hydrogen sulfide and things of that nature, so there's different things that we can do to help with different wastewater options. 3-Tier is a diverse company, and we're a little different than other manufacturers that are out there for a couple of different reasons. We have a complete internal science team, both that deals on the micro portion of our products to the enzyme portion of the products to the biopolymer that is a very unique product. That's the foundation for all of our processes. We're also the manufacturer for all the products. So if we have to make alterations or special one-off products, we can do it because we are a just-in-time producer. We can quickly adapt to different things that our customers need. So you're always getting fresh product, and you have things that you need as quickly and effectively as possible. The biggest part that we strive on is our experience. I'm an agronomist by trade. I know how to grow stuff. I'm a soils guy for over 35 years. Used to be a golf course superintendent. I've dabbled in agriculture. But when it comes to remediation, it's fixing soils and making them active again. And that's what I'm really good at. We also have a complete team of agronomists and other soils guys. We also have a complete team of water guys. Their specialty is how do we deal with different water situations, whether it's groundwater, wastewater, pond water, produced water, Our support and what we bring to the table is pretty massive. But what does that mean to you guys? Well, I get involved in, I would say, pretty close to 75–80% of our projects. Why? To ensure that you guys aren't just buying a product, saying thank you, and left on your own to figure out how the product's going to be used. We work with regulators, we work with CAP plans, we understand the processes from state to state that we have to do to get regulatory permissions, get the products approved, but more importantly, we want to make sure that we're working with you, the clients, so that if you have a particular situation that occurs on a regular basis, we'll help you figure out effective methods, whether it's finding contractors to go ahead and help do it, or work with companies like George Edwards, who's finally back in the room, my co-host for this event. Thanks for coming back.
Yeah.
Appreciate it. But the job is not just getting you a product and hoping that it works. 90% of remedial failures is because the products, one, either don't have enough data behind them to get a proper technique and a proper process, or they are applied improperly. Today, we can't afford to have those mistakes. Those mistakes are very expensive. On the flip side to that is also a new day from the standpoint, instead of going, oh, well, we'll come back to that small spill in a couple of months and we'll take care of it then. Well, as I will show you, it only takes about a day for sodium and chloride in soils with any kind of clay content to completely change the dynamic of that soil. And every day after, every week after, every month after, that problem gets worse and more expensive to fix. Me as a product manufacturer, take as much time as you want. It's not effective anymore. So today's message is going to be more speed. More or less not pass up the opportunity to do it on a day-to-day basis or a month-to-month basis, because your cost to actually go ahead and correct these problems are going to be fractional in comparison to letting them go longer down the road. We bring our science team in for product design. I travel the world in oversight or consultation of projects. So I'm pretty familiar with most of the equipment that's out there, most of the methodology that's out there. So we can help figure out the best ways to use our products and to implement them into different situations so that we have the proper and most effective way to get the results. Quick rundown on our technology, and I'm not going to spend a lot of time on this, but it is an interesting technology where the primary component is a biopolymer. It's a large carbon chain. And that's the first 3 points here. Why is that important? Well, I'll reference back to this slide as I go specifically through produced water spills and bioremediation and how that impacts. But there's a couple interesting points. Our natural biopolymers are both positive and negative. Why is that important? Well, we're asking them to work in a lot of different environments, and everything that we deal with have energy charges. A produced water spill is very interesting because it has two different charges that we have to deal with. Salt is positive, chlorides are negative. Well, now you're dealing in a dual range situation that sometimes is difficult. Just throwing calcium or lime or organic compounds on it and trying to flush it with a lot of water is something that you can do and will eventually work over time, but it can also be pretty pricey and can potentially increase the size of that spill. So when you have something that has both charge ranges in there, and we're dealing with metals, dealing with sodium and chlorides, you have a better ability to work within those zones because the product reacts better to it. Hydrophobic and hydrophilic, pretty simple, big words. One attracts water, one repels water. Why is that important? Well, if you're doing anything from bioremediation, bugs don't have legs. They don't move. So the only way that you move bacteria around for remediation is via moisture. So if you don't have the proper amount of moisture in soil, you're not going to get any kind of good remediation. So it's a movement tool. It helps your soil, helps the structure, helps move materials around so that they can be consumed and remediated, or we can actually get to the targets. It also reverses some of the problems that we'll explain, especially in sodium and chloride spills. That really locks up your soil. So having something that can attract and also repel water helps in that remediation. Again, it's a long chain molecule, one of the largest molecules that are available out there in the marketplace. What does that mean? Well, I'll talk about that a little bit more later. The interesting part is we also bring other technologies to the plate. When it comes to remediation, your organic structures are generally large. And again, going back to bacteria, they're very small, they're very lazy, and they don't have mouths. So if you're trying to give them a hoagie sandwich, they're not going to be able to eat it because it's too big. So they're not going to eat it. So you have to have a componentry in there that can fractionalize and break down organic long chain molecules to make them smaller. So turn apples into applesauce. The simpler the form that the contaminant is, the easier it is to remediate. A lot of times a hydrocarbon spill left alone, a lot of people will think that, well, over time it's going to naturally go ahead and break down and go away because there's millions of microbes in every square foot of soil. The problem is that the actual spill, the contaminant, becomes a preservative for bugs. Bugs that are put into an adverse situation go to sleep. They go dormant. My bugs that are in my product, we use a natural preservative package to basically put too much sucrose in there, and we put them to sleep in the jug. So they're active bugs. All you got to do is dilute them. So it's very easy to use, long shelf lives, a simple product that has different characteristics in it to take care of a wide range of actual solutions or problems that we actually have to fix. So I mentioned a couple of things. When we have a spill, there's a lot of changes that go on within your soil structure. One of the first things that we generally do, or we need to do, is try to reinvigorate those soils. How many regulators do we have in here? Can't listen to the next statement. If it's growing, they're probably not going to look at it very hard. Soils that are contaminated generally don't grow things. The value of our techniques and our processes is that as we're remediating and the levels are going down, you're going to immediately be able to get vegetation coming back into those sites. We are going to protect and build a protection layer within that environment so that the vegetation can start reestablishing itself, even though the levels aren't all the way down to the regulatory side. And we still have to get to particular points. Because OSU did a great thing over the years when they were developing the new soil testing for sodium and chloride spills. They bring in a lot of the different key components that we like to see before we treat something. But one of the things that they identified is certain EC levels that demonstrate the ability or the inability for plants to grow within soils. And they're pretty accurate on that. That 4,000 is pretty much a high threshold, and you have to have a pretty hardy plant that's going to survive. Once you start dropping below 4,000 in conductivity, your soils generally can grow things. But we can generally push that gap a little bit higher. We can get soils active because, again, our technology is providing a level of buffering, an ability for the soils and the plants to go ahead and start reestablishing themselves and repairing themselves, even while we're still getting the regulatory levels down. So the nice thing is, and we have a couple of things on our produced water side that will demonstrate, even though the levels are still high, we have big active growth and regeneration within these locations that help go ahead and turn the area around so that you're getting reestablishment. Why is that important? Well, again, look is important. Regulators today, if they're driving around and see a big wide open bare spot, light bulb's gonna go off, something's wrong here. If stuff is healthy and growing in and around a disposal site or a production site, or most of our exploration sites are out around agricultural land or pasture land, if those are still active, cows can still go ahead and graze, the farmers can still go ahead and grow it, then it demonstrates that you're doing your job to keep those soils cleaner and better and more active. Sodium and chlorides, produced water, probably the number one battle that we deal with in a lot of explorations around the world. Sodium chloride is an element. I can't consume it. I can't degrade it. So what am I doing with it? Well, before I tell you what I'm doing with it, let's kind of look at some of the things that it does. As I mentioned before, most of our soils have some sort of clay content in it, especially in exploration areas or your pads, because clay is used for stabilizing. So one of the first things that salt does, because it's positively charged, is it's going to react with the charges in clay that are negative. The negative charges naturally push the clay molecules apart and keep them apart. So moisture will go down and through, the soil's healthy, you can grow things, moisture flows, it's all nice. Within hours of salt hitting clay soils, it's going to start reacting. The positive charge goes to the negative charge, it pulls it out, that clay starts collapsing. Does anybody ever notice after a production water spill, moisture kind of starts running over those areas where that produced water was? Why? Because the sodium in it has locked up the soils. It now isn't allowing moisture to go down and through. Well, that's actually the number one cause of death to the plants. Not the sodium or the chlorides that's really involved. Obviously, if you have high levels, the plant's not going to like it. But it's not the number one cause. What happens is your soil now no longer can get the natural moisture going in and out of the plant tissue and in and out of the roots. What happens is all the moisture starts getting pulled out of the plant because everything's drying up around it. Moisture can't get to it. So the soil naturally starts reversing that process. So now you got too much moisture being pulled out of the plant, and plants generally die because they dehydrate. That's the general number one cause that happens. So now you have the soils that are all nice and tight. Moisture's not getting down and through, nutrients can't get to the plants, moisture can't get to the plants, and that's what happens, the plant dies. And because you don't have moisture there, you're not going to be able to easily revegetate it. Even if you cultivate it, open it up, flush it, the problem is that the sodium has already done its job and it isn't moving. So we have to have a method to go ahead and desorb that sodium and chloride. Now on the chloride side, chloride is negatively charged. So if we have a product that can take care of salt, 9 times out of 10 it's not going to do a whole lot to chloride. And the chloride portion of most remediation processes are more scrutinized by regulators Even though they still are concerned about the sodium, chlorides is generally that one that's very difficult to get within a regulatory range. Because again, I'm not consuming it. Would you guys agree with that? Or not? Or both are important? See, I'm going to keep picking on you guys. I love having people pick on. Or would you say that they're equally important?
Equal.
Equal? Okay. Well, certainly the salt side is important because that's the main one that's killing your plants. And that's the one that's making these big, ugly areas that we're trying to fix. So that's where you have to have a technology that's able to work in all of it. So our core technology that we use for soil for sodium and chloride remediation reverses that. Because our polymer is both negatively and positively charged, it can go in there and reverse and hook onto that sodium molecule and replace what it's attaching to. So our molecule now pulls it back away. And because our molecule is also moving moisture into that area, it's going to help push the moisture in and through, get our product in there, and again, reverse what the sodium and chloride is doing. So it's a similar process to just using lots of calcium, cultivation, moisture. But the problem with that process is that most calcium that we use or is suggested to be used on projects or organics, it doesn't have the mechanisms to react immediately. They will over time. So either you're going to need tons of moisture to go ahead and keep flushing the material down and through the profile because it doesn't have a mechanism in itself to get to where the problem is. Or it doesn't have the ability because that area is still hydrophobic. You haven't done anything to change that characteristic for the ability for moisture to go ahead and get into it. That's kind of where our technology goes. We're using the same scientific principles, but how we deliver it and how we're able to go ahead and make the actual process work is all built into a single jug, a single product, where you simply just have to dilute it and add it into water. And this is where I'm going to do the natural break because I see lunch is starting to go in. I'm a very visual guy, so it's easier for me to understand. So when I say that as soon as sodium and chloride goes ahead and hits soil with any kind of clay content, it goes ahead and locks up. This obviously isn't going to allow a whole lot of moisture to go through. And I'm sure if you guys have seen enough produced water spills that are out and about, which I know there's a couple around the state, it's going to look very capped off. You may even see a little white sheen from the actual sodium chloride buildup that's on the top. And it's going to stay that way. And water is going to just kind of go across the top of it. It's not going to percolate down and through. You're not going to see much different. This is healthier soils. This is what you need to be able to grow something. Something that's still going to have some larger pieces in it, aggregate, but is also going to be tilthy. It's going to be open. It's going to have the ability to move materials down and through. It's going to make it easier for a plant to grow in it. A plant will grow in this quickly, easy, and effectively. Not so much here. So with that, we'll take a couple minute break, let them finish getting set up so we're not, and this is a good natural break point before I go to the next slide. While we're waiting, any questions on what I've covered? And that's the important part. If you got a question, thought, anything along the way, jump right in. This is kind of a, hopefully more interactive and not one-sided.
What kind of effects do you see in water? So a spill into a water body instead of into soil.
Great question. Sodium chlorides, and a lot of people have asked us, well, can we take our product and can we treat produced water to minimize the effects of the sodium and chloride in that produced water as it's being transported and things of that nature? Unfortunately, there's one critical mechanism that our technology also needs, and it's some additional organic structure. Now, in a tank, trying to deal with treating produced water in a tank, we don't have enough organics or enough loading to offset it to be cost competitive. We can add enough product to get the result, nobody will pay for it. Now in a lake, we got a different scenario. We have a bottom, we have organics, we have natural organics, TSS, dissolved solids, different things that we can attract to. So if you have a spill that goes into a body of water, can we effectively go ahead and help reduce some of those negative effects? Yes. Especially protecting fish, trying to neutralize that negative impact. But I'm not going to stand here and tell you that I can go ahead and treat a tanker load of produced water, and if you spill it, it's not going to have a negative effect. It probably won't, because the treatment is in there, and it'll be better if it hits the soils. But I'm not going to change a whole lot of the chemical characteristics of the sodium and chloride in just a tank load of produced water. I can get rid of the hydrocarbons, but it's very difficult to deal with those two in an aqueous solution in a concentrate. Put it into a water column like a pond or a lake or something along those lines, and again, because our product's all organic, it's not going to hurt anything. It will help neutralize, but we can help precipitate the sodium and chlorides down to the bottom.